Welcome to Code Club. We're here with the usual Gopher crew to do some looking at Go code and thinking about it, and I thought this week we might have a crack at some refactoring, which is always fun, isn't it? Everybody know what I mean by refactoring?
Yes.
Good, what do I mean?
Yeah.
Maybe you can help us start to explore that idea.
So it's usually restructuring existing code. So it might be without changing the behavior of it. Is that correct? It might be improving or putting multiple functions into one, all that sort of stuff. So it's kind of improving the implementation of it.
Yeah, I think that's a pretty good summary, isn't it? It's the point you made was the important one. I think that it's about changing code without changing its behavior, isn't it?
That's what I aim for. Usually we end up changing behavior.
Yeah, that's right. A successful refactoring would not change behavior. So, the examples that I'm going to look at today are from Exorcism. Is everybody familiar with Exorcism? I know some of you are. Well, I'll say what it is just in case. It's a website, exorcism.io, where you can sign up and you can do code practice in a bunch of different languages, so there are problems for you to solve. You submit your solutions and some actual human being will look at them and give you feedback on them, hopefully. There's a bunch of sites where this process is sort of automated, isn't it? If your solution passes the test, it'll tell you that and you can move on or whatever. But I think the really great thing about Exorcism is the human being involved. When I started learning Go, that was one way that I started, by signing up on there and trying to do problems. And it was super, super useful to get feedback from someone saying, yeah, this is fine, but here's what you'd actually do. Introduce me to the idea of sort of idiomatic Go and better solutions for things and ways to refactor programs so that they could be shorter, clearer, more efficient, better. Has anybody been through that process themselves who'd like to comment about it?
I've been through Exorcism. That's how I found and joined your group.
Great.
In the first place. I found it incredibly useful. While I have a lot of experience with software, with Go, I hadn't had as much, and it was great to get targeted feedback, particularly on what's idiomatic.
Yeah, it's nice, isn't it? And it definitely, from a personal point of view, it's made a huge difference to me. I mean, I learned a ton from doing Exorcism problems, and when I signed up to do the mentoring, that taught me even more. It's also sort of, I got so many people contact me on Exorcism saying, can you give me more mentoring? I'm happy to pay you, sort of thing. I started thinking maybe there is a business in this. So, from a very selfish point of view, I've got Exorcism to thank for launching this business. And it's also brought me together with lots of really nice and interesting people, which is also great. Some of them here today. So let's get into it then. So has anybody done the Scrabble score exercise on Exorcism?
Long time ago.
Yeah. So it's essentially the problem is, given a word, score it as a Scrabble word based on the points for letters. I'm sure everybody's familiar with Scrabble, but if not, different letters have different values according to this table. So just to sort of get our brains in gear and start thinking about it, anybody like to speculate about how we might approach this problem in Go? It's not desperately hard, is it? It sort of sounds like some kind of loop, perhaps, some kind of way to look up these scores. What do you think? Any suggestions?
I would start with a map of letters and values,
Yeah.
and then I would iterate over each letter and check which value it is in the map, and just like summon.
Yep. Sounds pretty reasonable, doesn't it? So let's have a look at this particular attempt. So this is in no way, you know, I'm not singling out this solution as especially bad or anything like that. It's just I saw it and thought, yeah, I feel like this is a nice example of some refactorings that we can do. So here it is. We define a type called letter score, which is a struct with a slice of runes and a score for them. So we're going to do like, here are the 1 scoring letters, it's this lot. Here are the 2 scoring letters and so forth. And we put them all into a slice of letter score. And the global variable scores, so that's alright, isn't it? And here's the API is the score function. This is going to be called by the tests with a bunch of different words, and it's going to try to score them. So it's exactly what we said, isn't it? So we're ranging over the word. For each letter we're going to get the score for that and add it up. So as you said, Thiago, it's just the sum of all of those scores. Notice we're not handling things like double letter scores or double word scores or any of those. That's like a stretch goal for this exercise, but it's not attempted here. So here's get letter score. So let's see if we can figure this out. Sherif, could you help us by just sort of describing what you see here so that we can get an idea of what it does? We've got a rune as input, haven't we?
Yes. So
And we return an int.
yeah, it's like a loop, right?
Yeah. So we have a loop here, yeah. And what are we looping over?
Every value from above we're trying to. So sorry, can we go up again?
Yeah, that's right. This is our big slice of letter scores that we saw. So that's our outer loop, and then there's another loop inside that, isn't it?
Yes. Yeah.
Just talk us through that.
The first one, yeah, is looping the letter in story. The second one, I don't know.
So let's check the type again. So this struct has got a letters field, which is a slice of rune, and it's all the letters that score that value, if you like. So we're like, if we look at this, then here S will be our first letter score, which will be the 1 scoring letters, and we'll range over all of those letters, and then what do we do?
It's calling this letter is just you're getting the value, the score value, right? And then you're trying to get the score value.
Yeah, so first time round this loop we might be looking at the 1 scoring letters, for example. So we will have A, E, I, O, etc. So we'll be ranging over each of those letters, and for each one we'll be saying, is it the letter that we're trying to score? So suppose A were the input to this function, for example. Then we'd start looking at the 1 scoring letters, and then we'd say, okay, is this letter A? Yes, it is. Okay. So we can use s.score, which is 1, and we can return that. So it's relatively clear how this works.
I think so.
Anybody like to suggest any way to improve this?
I mean, the first thing that comes to mind for me is this is remarkably inefficient.
Yeah, why so? I mean, I agree with you. I just want to surface what that's about.
You know, anytime you start to see loops within loops, you start to realize that you're compounding your computation time, you know, or growing exponentially.
Yeah, that's a really good point. Yeah, loops within loops are generally a bad sign, isn't it?
Yeah, I mean the kind of an alternate solution has already been suggested, right? Which is to have something with a shorter lookup time
Yeah.
associated with amount has been suggested. Certainly would probably work pretty well.
Yeah, this is a problem with Thiago, right? Is he's too good, always knows the answer. So a map definitely sounds like a faster way to look things up, because it if we're saying we have some letters and each one is associated with a numeric value, we just want to given a letter, we want to very quickly get the numeric value straight away. That sounds like a map, doesn't it?
Yeah, I've learned a few things about algorithm and data structure, and one of them is always I see loop inside of another loop. It's a bad sign. It's O n squared.
Yeah.
So the way to fix that is just create a map. It becomes O n.
Yeah. And some problems are inherently a two-dimensional grid in some way, like an image. Another of my mentees, Ben, is written a Mandelbrot set drawer. Shout out.
Game.
Yep. Shout out to Ben. He's not here today. But that's essentially a business of for every row in the image, calculate for each pixel what its color value should be. So that is essentially just two nested loops. Not really any other way to do it. But here, this is a sign that actually we've missed using a better data structure. So anytime you find yourself ranging over a bunch of things, checking each one to say, is this the one I'm looking for? Might be possible to rearrange those. Either you can arrange it as a slice so that the index number of the slice is what you look up, or a map. You could think of a slice as being a map keyed by monotonically increasing integers, couldn't you? So 0, 1, 2, etc. are the keys. And sometimes that's useful. So let's see if we can do this then. So let's just run the tests. Just make sure it actually works now. That's important, isn't it? Before you start refactoring, just make sure you actually have something that works. And to be very clear, we're interested in changing the code without changing the results of the tests in any way. I mean, we don't start refactoring until all the tests pass. No point refactoring code that doesn't work. And we want the tests to still pass at the end, obviously. So you could say, what's the point? I mean, I think this is at least arguable way to think about it, right? Is why refactor at all? If it works, it works. Ship it. Am I wrong?
No, you're not wrong. The reason to refactor is so many things. You and I talked about this just yesterday or 2 days ago. The reason to refactor has got so many different inputs. Maybe performance is an issue here, but what if it's not? Well, is readability an issue? This isn't super readable for somebody new. If that's not an issue, and this thing's going to go gather dust in a corner, well, maybe it doesn't matter.
Yeah. I mean, I think there genuinely are one-off programs, aren't there? Like, something that you cook up just to solve some problem you have right now, and you'll never use it again. So there really isn't a good argument for spending lots of time investing in the quality of the code, if you like. But that's all. But that's, most programs are run more than once, aren't they? So it's worth taking a little bit of time to improve them. I don't think anybody sits down and writes, clear, simple, beautiful Go code straight off. It's easy to get that impression when you look at other people's libraries and things. You look at some packages on GitHub and you think, yeah, this looks really great, and I can't understand how somebody can write code like this. You know, if you see like a big long list, you see some big struct definition with all these fields and complicated things, and you think, how did they know all this? You know, how did they know that's what they were going to need, and how did they design it all so it worked? And the answer, of course, is they didn't. You know, they just wrote whatever, trying to get stuff working, and then once they got it working, maybe they tidied it up. And then, of course, it evolved over time as they added more bits to it. So usually, at least my way of working is to try and solve the simplest version of the problem first. I'm not good at solving complicated problems. Not that good at solving simple problems, but at least it's easier. And then once I've solved that simple problem, I'll try and add a little bit more to the problem, you know, so it gets closer to what I'm trying to solve. So let's say, so suppose we had a map, like, so if we're making scores, a map of what?
Probably runes.
Yep, rune to what?
Int.
Int.
Yeah, int sounds believable, so there we had A1, B3, etc. There's a lot of typing here, and I see a lot of solutions to this problem where people have thought, I can't be bothered to type out all of this map. What I'm going to do is write an init function or something which constructs this map for me based on some structure like this, right? What's the problem with that, if there is one?
It seems a little overly complex.
Yeah.
Yes, the map will look big, but the reality is the alphabet's only 26, 27 letters.
Yeah.
I've seen maps that have hundreds of keys in them, thousands sometimes, you know, so.
That's right, yeah, Andrew's exactly right. It's not the end of the world to just type out 26 letters, is it? And by not doing that, we're kind of offloading the work from the author to everybody who has to read and use this library, aren't we? It's like, oh, I couldn't be bothered to type 26 lines, so now I'm going to make you understand code which is unnecessary. It only exists because I couldn't be bothered to do this typing. And I just think that's a really poor reason to ever write any code.
And also you are going to spend the same computation, right? Creating your map.
Oh yeah.
Iterative. So
yeah, exactly.
depending on.
I mean, you know, if once you built the map, of course, looking up the score is trivial, as we were saying. So in fact, you know, like 70% of the code in this entire library will just be generating that map. So I don't know. I mean, there are obviously legitimate cases where you might want to generate stuff like this, but I don't think this is one of them. So could we do better than this? I mean, could we... This map would be fine, but could we avoid having to even type out this map? What could we do? Suppose I framed the problem to you in this way. We have some unknown letter, or some known letter, and we want to say, if it's any of these, score it 1. If it's any of these, score it 2. If it's any of these, score it 3.
Sounding like a switch.
It really does, doesn't it? Sounds totally like a switch. I mean, of course, it could be literally if, series of if statements, but a switch is always a nicer way to write that. So it sounds like we're saying something like, this is no longer a var anymore, so let's move this inside this loop. So we're going to switch on this. So we're saying something like switch letter case these, and we can say like score plus plus, couldn't we? Case these. Already I'm deleting a lot of curly braces, which always feels good, doesn't it? Plus equals 2. Am I on the right lines?
You have an extra colon to get rid of up higher as well.
Did you say extra colon? Oh yes, yeah. Yeah, I don't need that, do I? And although this is a little bit laborious, I won't do the whole thing, you get the idea, don't you? And we could even say, if it's some letter that we don't know, what would we do in that case?
Score 0, presumably.
Yep. Now, and we've already done this bit, so we don't need it. We don't need any of this because it's all done. And we don't need that, which is great. Anytime you don't have to define a type, that's a good day. Can we refactor this? Or are we doing about as well as we possibly could?
You could add lines of code to essentially make a type around the certain letters that fit, certain scores. That's going to add code and complexity probably. So doesn't seem like it can get much more simple.
Yeah, one thing we could do is, since adding 0 to a variable doesn't change it at all, we don't really need that case. We can just eliminate it, can't we? Or is it not clear that we can eliminate it?
Given that your set your set of things is defined, right?
Yeah.
It has a limit. Then no, you don't need a default as long as your cases are covered, which your test should catch.
Yeah, and there you could say maybe there's a value in putting this here just to say explicitly, guess what? Unknown letters will score 0. But since this doesn't actually do anything, technically it's unnecessary. And we could have said maybe we return an error or something, right? Return 0 for the score and some error message saying unknown letter. And now we'd have to return error and so forth. And for a real Scrabble game, that's probably what we'd want to do, isn't it? We don't want to just kind of silently ignore invalid input. But for this exercise, I think that's fine. So that's a pretty good refactoring, isn't it? Like, we got rid of a type definition, we got rid of an extra function, we got rid of an inner for loop. Any guesses about how this performs relative to the map implementation?
I assume it will perform very similar to the original implementation, because with a switch, well, no, it will run, a switch will evaluate each case concurrently. That's my main question. Is it actually looping through each case, or is it actually evaluating?
Yeah, good question. I don't know. But it seems, if we're saying, like, we could create this slice, and then we could loop over it ourselves with a for statement, checking equality with letter for everyone. But we sort of feel like whatever the compiler's going to do to implement this is going to be better than that, isn't it? I mean, it might not be. Might just generate a for loop. I don't know. We can look at the object code and find out. But I feel like there'll be some efficient way to do this. And you know, clearly,
looks like it evaluates top to bottom.
right? Yeah, that makes sense. Yeah, the first case that matches, and then that's it. That's the end of the switch. So unlike some languages, you don't fall through to the next case, and so forth. That's
Yeah, but it can be the last letter. So right, if you for considering the algorithm, it's always the worst case.
yeah, and yeah, that's right. So that's a good point that different letters will perform differently. So if the input word was all A's, no doubt this would be very fast. If they're all Q's or whatever, that's not going to be quite so good because we will have had to exhaust all of these every time.
It's been a while since I did this exercise, but most of the exercises, some of them in the test file would have benchmarks.
Yeah.
Benchmark tests. So I guess you just try a couple different implementations and run the benchmark.
Yeah, that's a good idea, but what would we need to be careful about with something like that?
I guess it depends on what machine you're using. It's one of them, you know.
Yeah, that's a great point. Yeah, that's one thing, is it's only going to tell you how fast it is on your machine, but you could at least use that to compare two different strategies, couldn't you? You could compare map versus switch on your machine, and you could say, if it looks like, you know, map is significantly faster, you could say, I assume it'll be faster on any machine. But is there anything else that we need to watch out for with benchmarks? I mean, it's great to be able to benchmark stuff, and the benchmarking tools are really good, but their use as a decision-making tool is slightly constrained, right? Anybody think what one of those constraints might be? How does a benchmark work? It works by repeatedly calling your function with some input.
Maybe
The CPU cache. Sorry, go ahead.
No, you're right. I was thinking that number of loops it actually runs could be different.
Yeah, that's an interesting point actually, because it, you know, clearly if we just called this function once, the execution time wouldn't tell you very much, because lots of other things could be affecting it. You're doing other things on your machine and so forth. So statistically, you'd want to run it a bunch of times, wouldn't you, for some large value of bunch? And that's exactly what it does. Is it tries to run it enough times to make the overall run about 10 seconds or so. So it runs it. It picks some number like 100 and runs it that many times. It says how much wall clock time has elapsed. Oh, not enough. I'll run it a few more times. And it keeps increasing n, which is why n is something that's passed into you as part of the B, which is the magic benchmark object. So another way to say that is if your function is very fast, it'll be called 100 zillion times, whereas if it's quite slow, it won't be called that many times. So the stats will be more reliable on faster functions, let's say. And of course you can have longer runs yourself if you're interested in. But all of that said, still only gives us the performance for this input, doesn't it? What is that input? Let's have a look. So, yeah, this is all right. This is probably about as many test cases as I would write for something like this. But if we're interested in performance, these are not particularly large inputs, are they? I mean, there's one here which is 26. We could imagine, couldn't we, that maybe one or other implementation is quite fast for 26 letter string, but performs much worse for larger inputs. Does that seem reasonable?
Yeah, or maybe if you add Z, 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 Z.
Yeah, that's right. So what kind of what kind of issue might cause that sort of performance curve? I mean, we know intuitively that it's not necessarily linear, don't we? Like, if, let's say, maps are faster for these inputs than switches, does that mean we can guarantee maps will always be faster? Why would the two algorithms start to perform differently for different size inputs?
Because the map is just one access to the memory.
Yeah.
So I think that's the faster you can have.
Yeah, and actually, an interesting thing about the implementation of maps in Go is that they're constant time. So, you know, a map is a hash table, so what you do is you hash the key, like Z. It tells you which bucket to look in for the answer, and you go look. That hash function is designed to always take the same time, no matter how big the input is. So, you know, if you had a 1,000-character string, for example, and you had to hash it, it takes exactly as long as hashing a 1-character string. That's quite an interesting property, isn't it? Anybody like to speculate from that what the performance curve looks like, in fact, for these two strategies?
Sorry, can you repeat, please?
Yeah, there was some UFOs interfering there. Saying, given what I just said about the way maps are implemented, does that give anybody a clue to guess how map versus switch is going to perform with different size inputs? Remember, we've said maps are constant time, and the switch, of course, is just linear. You just have to go through all of these.
Yeah, I think it's like O1 for the map, and ON for the another implementation for the case.
That's right. O1 means constant time, yep. And ON means linear with the amount of inputs. So it doesn't really affect this problem, but we could imagine, you know, extending this to more letters, couldn't we? Like, if you've got to score all 150,000 Unicode characters, that would be very sensitive to the actual characters. So if you used, you know, the last one, the equivalent of Q or Z or something, it'd take a really long time to look it up, whereas the map time would be constant. So what you in fact find if you benchmark these is that maps do quite poorly relative to switch on this benchmark because it's just small inputs. But, you know, you'd be wrong to take away the lesson that it's always better to use a switch, because in fact maps rapidly outperform. You know, O1 could be beaten by ON for small n, couldn't it? But as n gets big, it's much bigger than 1. So you could think of it as there's a fixed time overhead for hashing the map key. So even ON solutions can beat that at the beginning, but then the ON solutions get slower and slower and slower with n, but the O1 solution stays the same. So for almost all values of n, certainly big ones, maps are a really good idea. So it's lovely to know that property of maps from a scaling point of view. Anytime you have, you know, scale and performance issues in Go, you might think...
May I do a comment?
Yeah, sure.
It's more a question. I heard probably in Python once that the map was slower because of hash collisions. So like it was generating the same hash for different letters, and what Python does is create a node and create like 2 pointers inside of this node.
Yeah.
So does it happen in Go?
Well, it's definitely something this isn't really to do with refactoring, but it's interesting. Designing a hash function for maps is a pretty specialist job, because you want various characteristics. Like, you want it to be pretty fast. You would like it to be constant time. You would like the keys to be, you'd like the buckets to be well distributed. So you don't want everything to hash to 1, for example. You would like to have the minimum number of collisions, which is sort of related to that, isn't it? The more well distributed the results, the less likely they are to collide. And you also want a big domain of outputs. And there are lots of other fascinating things about hash functions, which we can talk about another time. But essentially, let's summarize this then as saying switch is nice and clear. It's easy to write compared to a map, and it's fine for this case. But maps give us constant time lookup, and it's very simple code. It would just literally be score plus equals value of letter. Now that's the kind of program I really like. Right, it's hard to imagine it being simpler than that. I just want to take a moment to tell you about a series of ebooks I'm writing for Go beginners called For the Love of Go. In book 1, Fundamentals, I show you how to write tests in Go and how to build programs test first. In book 2, Data, I tell you all about variables and values in Go, and data types like slices and structs. If you're new to programming or just new to Go, I'll show you everything you need to know to start building fun and useful projects. Go to bitfieldconsulting.com/books and enter Code Club at the checkout to get 25% off now. So let's look at another one. So this is a bit more of a complicated problem. And maybe we can't refactor the code to be quite as small as in the Scrabble example, but let's see what we can do. So, anyone familiar with the LUN algorithm? Especially if you've done this exercise on exorcism, you now will be.
Only from implementing it in exorcism.
Right. So it's an algorithm that's used a lot of places for validating numbers, like making sure you didn't mistype the number or something. Credit card is an obvious application of that, social security numbers, things like this. And what they do is, given some number, let's look at some cases, you start from the right hand end of the number and you double every other digit. So in this case we would double the digit 8, and we would say if it's more than 9, subtract 9. So you could think of it as being mod 10, couldn't you? With no carry. So we would double this as 16 and subtract 9. That gives us 7. So we would change that digit to 7. And we carry on doubling every other digit until we get to the end. And then we sum all of these digits up, and the result needs to be exactly divisible by 10. So that might sound a bit weird, but what that effectively means is we would add some check digit onto the end to make it valid, wouldn't we? So one of the first commercial programming jobs I ever had was data entry for a business for taking orders by credit card, and we implemented this algorithm to validate a credit card number. So being a hacker-minded sort of person, of course, the first thing I did when I got home was reverse that algorithm to just generate as many valid credit card numbers as I wanted. Don't do this at home. But that's how hackers think, isn't it? This slightly involved and pointless seeming process just lets us check numbers. So here's some code that implements that. Now, how do we... I think if somebody tells you a problem, you sort of are able to form an idea in your mind about how long and or complicated the required program would be, wouldn't we? Does anybody have that thought process?
It's usually not what happens in reality, though.
Yeah, that's
Usually
right.
overly optimistic. Oh, it'll take me an hour.
Yeah,
And the end of the workday, I'm still working on it.
yeah, that's right. But I mean, at least our inability to predict how long something takes is predictably inaccurate, isn't it? As Hofstadter's law says, everything takes longer than you expect, even when you take Hofstadter's law into account. So it's recursive. But yeah, if I said to you, for example, generate the numbers 0 through 9, you could sort of form a mental image of the program required, couldn't you? Even though you wouldn't necessarily know exactly what it would be, you'd be able to predict it's a pretty short program, right?
Yeah, I mean the problem that's described seems just kind of like, a loop through the input, hopefully once. So if you can figure that out, then the problem will, okay, I only have to run one loop here. The mental space is small,
Yeah.
so I can get it done in, under half a day.
Yeah, that's right. And I suppose what I'm trying to get at is we have some kind of refactoring sense in our minds, don't we, which is sort of built up through experience of programming. And when we look at a program, we can see if it's long and complex or whatever, and we think maybe we could make it shorter. But if we know that the problem itself is long and complex, we're less confident about the scope for that, aren't we? Whereas if I told you it's a super simple problem and then, generate 0 through 9, and then I give you a 100-line program, instinctively, surely most of those lines are unnecessary. Unless you're in one of those obfuscated code competitions, Sometimes we can be wrong about that. I mean, the Mandelbrot set is a good example, isn't it? If you look at an image of the Mandelbrot set, seems so rich and structured and complex and full of interesting things, and in fact it's full of infinite detail, isn't it? You can keep zooming in and it never gets less interesting as long as you look at the right place. So it seems like the program to generate that should be super complex, doesn't it? I mean, I'm always astonished when I look at implementations of Mandelbrot programs, and it is literally like 5 lines. Five or so lines to calculate the value of each pixel, because what we're doing is repeatedly applying a mathematical function, and we're just seeing what happens to the values that you get. Do they diverge wildly to infinity, or do they stay within a fairly small window? And that's very simple, and we just do it for each pixel, and this incredibly rich structure emerges, and that's just inherent in math, if you like, isn't it? It's just built into numbers. I find that slightly baffling and wonderful. But again, it's nothing to do with what we're talking about. So let's dig into it then. Let's see what we can do with this. So should we try and understand it first, Code Club style, what this is doing? So remember, the idea is we have to double every other digit from the right, and then sum up all those digits and check they're divisible by 10. So that doesn't sound on the face of it, like an 81-line problem, but let's see. So here's the entry point. Valid gets called with your credit card number or whatever it is. It's going to return a ball saying yes, it's valid, or no, it's not. We call some function and remove spaces. I can guess what that does. They've helpfully commented it, thank you. And then, so it's saying if the length of the input without spaces is 1 or less, it's not valid. So that's another of the LUN rules. You must have at least 2 numbers. But assuming that's not the case, then we call this function, which presumably does the every other digit doubling, and then we sum them, and then we check the divisibility of that sum. So just looking at this, without even diving into how those functions work, Anybody see anything? Anybody's refactoring spidey sense tickled by anything here?
I mean, two things.
Our
Sorry, go ahead.
our rule of don't use else.
Yeah, that's else is almost always a mistake. So I'll just run the tests, make sure we're all good. Yeah, it's all good. So let's try eliminating else. So we could have just returned false here, couldn't we? Now we don't need else. So we can unindent these, and that helps with readability. Goes 8 space tab thing means
It's missing the return at the end.
yeah, right, I'll get to that. So goes 8 space tab thing kind of helps us write better code in a way, doesn't it? Because if you have more than a couple of levels of indentation, you're kind of way over to the side of the screen. You can't even read that code anymore. So it's telling you don't indent that much. You've probably done something wrong. Try an early return, or some other refactoring. And I see people who set their editor up to display these tabs as 2 spaces or 4 spaces or something like that. And I understand why they do that, because they don't want all their code falling off the right hand side of the screen, but they've sort of that's a shame, isn't it? Because then you've lost this helpful signal like, hey dude, you're indenting too much, just chill. So okay, yes, we need a return at the end. So this should still pass, shouldn't it? Yep. Great, that's a cool refactoring. What else can we do?
You don't need to name your Boolean at all, right? You can just return
Yeah.
some, at the end, you can just return whether or not your modulus of Thom is 0.
Yeah. Yeah, we definitely don't need to set some variable to x and then return it. Just return x.
Yeah, you don't even need to have the if block there. You can just return some modulus 10.
Right. Exactly. You never need to say if x return true, return false. You just say return x. Now I know from experience as a teacher that that's very far from obvious to a lot of people. And it's one of these things where, when you've done it a million times yourself, it's, you lose the ability to remember that once seemed difficult. And I think this is one of these things, I don't actually know, let's write it in its fullest, wrongest form, right? Something like this. I think, some of us could look at that and say, of course, that's equivalent to just return x. But other people would have to think through it. But I think if you think your way through it, you can sort of satisfy yourself, can't you? But that's what's going on. You're saying if something is true, then return true. Or if something is false, return false. Well, I don't need the if. I can just return something. Maybe if you have a traditional CS background, you're forcibly put through courses in Boolean algebra and so forth in CS 101, and maybe, you could do much more complex algebra than this, but this would be one of the first things you learn, isn't it? So maybe people who haven't got that background find this difficult, and that's definitely not me saying you have to go get a CS degree if you want to be a programmer. We know that's not the case. Nonetheless, some of the things you would have learned on that course will actually be super useful to you, and this is probably one of them. So that's great. Anything else we can do? I think that's pretty good, isn't it?
Is it actually an early optimization to do the first if? Would not double digits be written in a way that it should return the correct output if the input? I know it should remove spaces be probably in double digits. Why would it be here?
Can you say a little more?
You're removing spaces in 2 spots, but also
Yeah.
want to kind of an optimization
Yeah.
of if the string's not long enough.
Oh,
Shouldn't
yeah.
double digit be able to handle that itself?
Yeah, so you could say something like input is remove spaces input, and then we don't need to call it again. Is that what you're getting at?
Sort of, I think that too, but I also wondered if maybe that removing spaces should be handled inside double digits.
Yeah, maybe. Maybe we don't even need these function calls. So let's have a look. So remove spaces. Okay. This is more or less how I would do it, I suppose. Any comments from the panel on this? I think you know by now that I wouldn't ask unless I felt there was something we could do.
I think we don't need a function for it.
Yeah, dead on. Why write a function for basically one function call? There's no point calling a function that calls a function. Let's just delete all of that. And it's an exported function as well, so it's part of our public API. Why? No need for it. Let's just do this. Anything else? I mean, that's great. Anything else? Here's one thing I would do is strings replace takes the string that you want to replace things in. It takes the thing you want to replace and the thing you want to replace it with, and then a number that says how many of them do you want to do. So if you only want to replace the first occurrence, you give it 1. If you want 2 and so forth, you can give it 2. -1 means all of them, but there's a convenience method for that called strings replace all, because that's so often what you want to do, isn't it? So it's I think I know why this is very common to see people using strings replace yada 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 -1. Anyone guess why that happens a lot instead of using strings replace all?
Because it appears first in the doc.
Maybe. That's a good suggestion. I hadn't thought of that, but my answer was I think it's the fault of Stack Overflow. I think people might Google for something like replace a string in Go, and they'll land on a Stack Overflow post where that's the answer, but it's from 5 or 6 years ago, and you know, this has been introduced since then. We've all done it. Stack Overflow-Driven Development, but you know, it has its caveats. So fine, so we got rid of the spaces, and you could imagine this is a good thing to do, right? If you didn't remove the spaces, it makes writing double digits really awkward. In fact, how would you do double digits anyway? Because you have to start from the right-hand end of the string, we know that, and then we check every other digit, but we can't just say every other character. We have to say ignore spaces, you know. So removing all the spaces is a great idea because first of all we can reject the resulting string if it's too short right away, and then it makes it easier to write this. And sadly I was too easily diverted into interesting digressions about stuff that I like talking about. So I was hoping to have more time for this, but can we think of any ideas in principle about how we might tighten up something like this?
I do have a quick question, if you don't mind.
Fire away.
Unicode.isDigit, wouldn't space spell that? And then it would fall down through the double equals 1. If it comes in valid result, that would then still, everything would work, even if you capture the string that had spaces in it.
So are you saying if if the spaces were still in here, it would fail this check.
That's what I'm asking. I'm not sure about it. I would assume a space is not a digit, but that may be a bad assumption without checking doc.
Yeah, I'm not totally sure. Spaces are definitely not digits, but I don't.
Not that I necessarily like this which I think could use some refactoring as well, but just with the way it's written right now, it looks like it would handle a string of spaces correctly.
Yeah, maybe. Maybe that whole thing is just unnecessary. And I don't think this is the right thing to do if you hit an invalid character. Anyway, you could just return false, couldn't you? Because it's invalid. The algorithm says you're only allowed spaces and digits. So anything else is an automatic invalid. We don't even need to finish the loop. We're done. What about this?
Would you prefer a for loop, a more traditional for loop, where you could actually just examine each? I don't know. I think it may be more efficient just to use a more traditional array approach.
Well, what I'm really getting at is, are you absolutely sure that I have to reverse this string before looping over it in order to implement the algorithm? Because that's an expensive business, right? I mean, you know already you've got to walk the entire string and build up a new one, so that's a lot of appends and so forth. And why, I mean, we don't have a range backwards operator, which would be helpful, wouldn't it? But do we actually need it?
No, you can use index.
It would depend on the length of the string, wouldn't it? Whether it was odd or even, because that would affect which ones you were needing to access.
Yeah, can you develop that point a little?
Well, let's say it's a string that's 3 in length, then the characters that you're interested in are the rooms you're interested in.
Yeah.
Where it's the third one and the first one, but if it's one that's 4, then you're interested in the fourth and second one.
Yeah.
So you would need to do a calculation to figure out which, whether you had an odd or even length string, and then that would inform your decision on where you start your.
Yeah. So just to footnote that slightly, I think you're saying if we said we're going to try ranging forward through the string, we've said we want to double every other digit from the right, but in fact if we know how many digits there are, we know whether we're on every other one from the right, don't we? So take the base case, a string of length 1, say the digit is 0, and we start at digit 0. Is it one of the digits we should double? Clearly not. Suppose we had a length 2 string, 0, 0. Again, let's start at the first digit. Is that one of the digits we should double?
I'm not sure about it, but what if I get the length of the input and I do a for loop from the highest value to the lowest, and I access the index?
Well, let's just try and answer this first question, shall we? As if you have a string of length 2 and you're looking at the first digit, should you double it?
No.
Actually, yes, you should, because we double every other digit from the right.
Right,
So if we look at the rightmost digit, we shouldn't double that one. We should double the next one we come to, which, as it happens, because there's only 2 digits in the string, is the first one. So the answer is yes. Let's take a string of length 3. Should we double the first digit?
No.
No. And what about length 4?
No.
Actually, it's yes. Because the first digit of a length 4 string will be
right.
every other digit from the right. So you get the pattern now, don't you? If the length of the string is even, then we should double the first digit. And if it's odd, as Bryan said, then we shouldn't. So actually we can range forwards now, can't we? If we know how long it is. We could imagine there's some bool variable which says double the current digit, let's call it double. If the string is even, we know we want to double the first one, so it starts true, and then what do we do as we go through the string?
We change the opposite.
Yeah, exactly. It just flips, doesn't it? So every time round we can just say double equals not double. So we eliminate counter because we no longer need to count the digits. We don't need this expression. We don't need any expression. We have a Boolean variable that tells us whether or not to double. Let's assume we can do the doubling. There's a better way than this. But there's no else because we can just... Yeah, we can just...
The other else also, and you keep the double.
Yeah,
exactly. Just...
So, yeah. So we don't need reverse. We don't need these, and we wouldn't need the double digits function because now it's just a single for statement, and we could move that right inside.
Yeah, I don't even want to try what I thought.
So, luckily, we don't have to read or understand this, do we? Because we no longer need it.
Mm-hmm.
And I'm 100% convinced that this also came from Stack Overflow. I don't believe anybody sat down and wrote that. But I think this is a useful lesson for us to take away, isn't it? That sometimes it's easy to look at a problem like this and think, okay, I know what I need to do, I just don't know how to do it. So I'm going to Google how to do X in Go. I'll find a block of code on Stack Overflow, I copy and paste it, my program works, I'm all good. The step that we missed was thinking, is that actually the right thing to do? Right? Maybe we don't even want to do it at all. I definitely don't. So sadly we didn't get to, and of course this goes away because we can just sum these digits as we go, can't we? Having doubled or not doubled the digit, we never need it again. So we can just add it here, and then at the end we can just return sum div 10 is equal to 0. So we can actually get this entire thing down from, what was it, 80 odd lines or something, down to about 15. It's basically that replacing the spaces and then loop over flipping a variable based on parity, doubling every other digit and adding it to the sum. So that's kind of nice, and it's one of my favourite exorcism exercises for just that reason, right? It's possible to add so much extra complication for perfectly understandable reasons and get very, very involved code. And it's really nice to be able to show people step by step, you can take that bit out, you don't need this, you can get rid of that, you can simplify this, and then you get down to a really nice looking program, and they're just going to like, wow, go rules. This is great. So yeah. It's always fun. All right, well, we better wrap up for today, but thanks very much to everybody for being here. It's been a lot of fun, and I'll see you next time. Bye-bye.
Thank you. Bye.
Thank you.